Lesson 4-3, Solving Equations by Adding and Subtracting. Let's consider the following problem. Let's imagine that you're saving up for a new iPhone case. You currently have $20 saved up. The new iPhone case costs $45. So how much more money will you need to save until you have enough money to buy the new case? Well, off the top of your head, you might be thinking, well, 20 plus 25 would give me $45. So the answer would be $25. And you would be absolutely correct. Now, if we were to write this as an actual algebraic equation, we would write 20 plus, instead of a question mark, we would use a variable, right? This x would stand for the amount of money that still needs to be saved. 20 plus x equals $45. Now, in order to solve algebraic equations, we have to isolate the variable or the letter in the equation. To isolate the variable simply means to get the variable by itself on one side of the equation. Well, right now, on the left side of this equation, we have a positive 20 and a positive x. Once again, our goal is going to be to get the positive x all by itself. So what do we have to get rid of from the left-hand side of the equation? Well, we have to get rid of the positive 20. We are going to use what's called an inverse operation to solve equations. What's an inverse operation? Well, if we're dealing with addition, the inverse or opposite of addition would be subtraction. If we were working with subtraction, the inverse or opposite of subtraction would be addition. So in this case, we are adding 20. What's the opposite or inverse of adding 20? Well, taking away 20. It's important to remember that in order to keep your equations balanced, whatever you do to one side of the equation, you have to do to the other side of the equation. So if I'm subtracting 20 from the left side, I must also subtract 20 from the right side. 20 minus 20 is 0, so we can cross it out. We are left with x equals 45 minus 20 gives us 25. So x equals 25. Then of course we can check our work to see whether or not we have the right answer. We can take our solution, 25, and plug it back into our initial equation. 20 plus, instead of x, I'm going to replace x with 25, equals 45. Let's see if both sides are equal. 20 plus 25 gives me 45. 45 is equal to 45. So this solution checks out. Let's try another one. Let's say I have x minus 5 equals 15. Once again, our goal is to isolate the variable, or to get the variable all by itself. So how am I going to do that? Well, in this case, on the left-hand side of my equation, I have x minus 5. I have to figure out a way to get rid of that minus 5 in order to get x all by itself. Once again, we are going to use an inverse operation. So what is the inverse or opposite of taking away 5? Well, adding 5. And remember, if I add 5 to the left side, I must also add 5 to the right side in order to keep this equation balanced. Negative 5 and plus 5 is a 0 pair, so we can cross those out. We are left with x on the left-hand side, and on the right-hand side we have 15 plus 5, which is 20. So x equals 20. And once again, you should check your work by plugging your answer back into the original equation. 20 20 minus 5 equals 15. Let's make sure it checks out. 20 minus 5 is 15. 15 is equal to 15. Our solution checks out. Let's try a couple more. Let's say that we have negative 5, or let's do negative 12 plus y equals 8. Okay, in order to solve for y, I have to get y all by itself. I have to isolate the variable. So let's think of which inverse operation we need to use here. Well, I think we can agree that negative 12 plus y is the same thing as saying plus y, or positive y, minus 12. It should be clear that in the equation we're subtracting 12. So the opposite or inverse of taking away 12 would be adding 12 to each side. Negative 12 plus 12 has a value of 0, so we can cross that out. We are left with y equals, this should be 12. 8 plus 12 is 20. So our solution is 20. Let's plug our answer in to make sure we're correct. Negative 12 plus 20 should equal 8. If it doesn't, we did something wrong. Negative 12 plus 20 is 8. 8 does equal 8. And once again, just to go back to our first step over here, okay, the way that I rewrote this problem, you don't need to do that. I simply rewrote it to show you that we were initially dealing with subtraction, right? You could have simply added 12 to each side. Remember, our goal is to make this have a value of 0. Negative 12 plus 12 has a value of 0. So that's why we can cross it out. Okay, let's try one more. Let's say x minus 7 equals 23. Okay, because we're initially dealing with subtraction, and that by the way, is the first thing you should always ask yourself, okay? What operation am I working with? Whatever operation you're working with, do the exact opposite. In this case, I'm subtracting 7. So I know that in order to undo subtraction of 7, I must add 7 to each side. Negative 7 and positive 7 has a value of 0, so I can cross those out. I am left with x equals 23 plus 7 is 30. And of course, we are going to take our solution, plug it back into our equation to make sure it checks out. 30 minus 7 is 23. 23 equals 23.